Everyday corporate work is not a vacuum. The moment a model leaves the sandbox and enters a live workflow, it collides with a messy, high-velocity stream of operational data. The sanitized inputs of the lab are replaced by ambiguous document scans, novel customer queries, and simple spelling errors. Faced with these variations, the model's rigid logic begins to fracture. The immediate operational symptom is a massive influx of false positives. The system raises an alarm for every minor deviation it doesn't recognize. Surviving this transition requires a conceptual shift we call the precision pivot. We have to stop measuring model accuracy and start measuring reliability. Deploying an AI based strictly on its validation accuracy sabotages the workflow. Instead of an autonomous agent automating a process, you create a bottleneck that requires constant human supervision just to clear the false alarms. The degradation of the accuracy metric happens through three specific transformations. The first is data drift. Real-world information is dynamic, while validation data is entirely static. This 2D feature space shows a decision boundary separating two categories of data. A model builds its rules on these historical clusters. As live data enters, inputs drift away from original parameters. The rigid boundary becomes obsolete, misclassifying new patterns. The second transformation is noise amplification. Real-world data is inherently incomplete and filled with irrelevant noise. Zooming in on this decision boundary, we see the model memorized the specific noise of its test set rather than actual patterns, a phenomenon called overfitting. The third transformation is context. A 99% accuracy rate is operationally useless if that 1% of errors consistently leads to catastrophic misdiagnoses or severe financial penalties. This results in alarm fatigue. When the system constantly flags minor, context-free deviations, human reviewers become desensitized to the alerts entirely. Prioritizing raw accuracy over adaptability creates brittle models. They achieve high marks in the lab, but possess no actual ability to generalize their knowledge beyond the exact parameters of their inception.